Hi everyone. We're going to make a table and graph the solution set for the following three equations on the different sides. And basically we're going to plug in the domain, find the range, write down the ordered pair, and then graph the discrete function. So we're going to do the first one. We have y equals x squared minus 3x minus 10. Our domain is going to be -3, -1, 0, 1, 3, 5. That's your solution set. And so basically we're going to plug in these values. So we get y equals, these are x values. So we're going to plug in -3 squared minus 3 times -3 minus 10. -3 squared is 9. Two negatives make a positive, so we're going to get plus 9 minus 10. So that's 18 minus 10 equals 8. So -3 gets paired with 8. And let's try -1. -1 squared minus 3 times -1 minus 10. That gives us 1 plus 3 minus 10. So when we plug in -1, this equals 4 minus 10 is -6. Okay, the next one is 0. Basically, you just plug in 0. That just gives you 10, because those two will cancel out. So 1 goes to 10. 0 goes to 10. Sorry. Thanks for telling me. Now let's do 1. So 1 is going to be y equals 1 squared minus 3 times 1 minus 10, which gives me 1 minus 3 minus 10, which is -12. So 1 goes to -12. And then we're going to plug in 3. And we'll try to get it all on this page. That means it's going to get messy. But 1 goes, 3 goes. So we have y equals 3 plus minus 3 times 3 minus 10. And that's going to give us 3 minus 9 minus 10, which equals -19 plus 3 is -16. So 3 goes to -16. And 5 is going to be 5 minus 3 times 5 minus 10. So that's going to equal -20. That's 5 minus 15 minus 10. So -25 minus 5 is -15. No, minus 20. Alright, so 5 goes to -20. Now we're supposed to graph these points. So I'm going to do, I'm going to graph everything by 2. So this will be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 is going to be up here. And this will be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So the first one we're going to graph is -3, 8. So this is -4. So -3 is going to be here. And this will be 2, 4, 6, 8. So we have 8. And this in between is -3. So we go here. And there's that point. The next one is -1, -6. -1 is here because we're going by 2s. So -1, -6. So this would be 2, 4, 6. -6 is here. So it's about there. And And the next one is 0, 10. That's easy. 0, 10 would be right there because we're going by 2's. I'm going to put these in green. Okay, so we've done this one, negative 1, negative 12. So 1 would be here. Negative 12 is negative 6, negative 8, negative 10, negative 12. So this is negative 12. So we'd be right here. I'm going to write this negative 12 here. All right, and the next one would be, we did that one, 3, negative 16. 3 would be here, negative 16 would go down further, 14, 16, so right about there. And then the next one, or the last one, is 5, negative 20. So this is 2, 4, this would be 5, negative 20 would be all the way down here. And I just graphed the dots. Let me change them so it's going to be purple. So we're going to have a point here, 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 and here. I just drew discrete points. Okay, the next one we want to do is y equals x cubed. So we have y equals x cubed, and my domain is going to be negative 2, negative 1, 0, 1, and 2. Now if I make a table, I'm going to make a table of my domain values, negative 2, negative 1, 0, 1, 2, and I have to find my range, which would be my y, by plugging it in. So I'm basically plugging in negative 2. I'm going to do this. I have 5 domain values. Everywhere there's an x, I'm putting a parentheses. And I'm going to plug in my domain values. And evaluate. So this is negative 2 cubed is negative 8. Negative 1 cubed is negative 1. 0 cubed is 0. 1 cubed is 1. 2 cubed is 8. So we're at negative 8, negative 1, 0, 1, and 8. And you want to write this as an ordered pair. That would be negative 2, comma, negative 8. Negative 1, comma, negative 1. 0, comma, 0. 1, comma, 1. And 2, comma, 8. All right. So you can remember these. They're pretty easy to remember. So I'm going to graph it. 0 goes to 0. Negative 1 goes to negative 1. Negative 2 goes to negative 8, which is 2 from the bottom here. All right. And then 1 goes to 1. 2 goes to 8, which is 2 from the top. So there's my points. I have 0, 0, 1, 1, 2, 8, 2, comma 8, negative 1, negative 1, and negative 2, negative 8. And there's my values. Okay, the last one we're going to do is y equals 3 to the x, and I want my domain values to be 1, 2, 3, and 4. That's my domain. So I'm going to make a table of values for my domain, which is 1, 2, 3, 4. I have to find my range. So basically I'm going to write y. I'm going to substitute my domain values for x. And y equals 3 to the 4th. And this is going to be 3, 9, 27, and 81. 3, 9, 27, and 81. Now, our ordered pair would be, the set of ordered pairs would be 1, comma 3, 2, 9, 3, 27, and 4, 81. So this is going to be a little difficult to graph on the graph paper I have on the iPad, but let me close that up. 1's going to go to 3. Let's go by tens, because we have to go all the way to 81. So this would be 10, 20, 30, 40, 50, 60. This is 56. Come on, pen. 60, 70, and 80. All right. So we had 1 goes to 3. So that's going to be right in here. 2 goes to 8. So that's going to still be in this area. 2 goes to 9. So it's going to be really close to 10. I know the scale's going to be off. 3 goes to 27. So this scale is off, but you get the idea. This grows exponentially. This is an exponentially function. And 4 goes to 81. So when you get to 4, you're way up here at 81. This is 80. So you get way up here. And it grows exponentially. Okay? And that's all. The next thing we're going to do is graph linear equations in slope-intercept form.